Next up, we want to test and see if the traditional mean is lower at the 0.01 significance level. So the test requirements are the same. We did those above. Null and alternative hypothesis. So the traditional mean is mean 1. So we're trying to show here that mean 1 is lower than mean 2. And then if that's not the case, we'll conclude that mean 1 is equal to mean 2. So there's our null alternative. Select the level of significance that was given to us at 0.01. Sketch our rejection region. This is a lower tail test. So we will have a rejection region on the left here. So if our test statistic is past the critical value, we will reject H0. So what is that critical value going to be? Well, this is alpha is 0.01 here. So we're using t-distribution here. So this area here, the rejection region, is 0.01. So this value down here is actually the negative of t.01. So let's find t.01. Do that with inverse t. Our left area is 0.99. And then our degrees of freedom are the n1 plus n2 divided by 2. So degrees of freedom are 15 plus 17 minus 2, which is 30. That's what we used in the confidence interval. Key that into the calculator here. So second variables, inverse t number 4, we want 0.99, 30 degrees of freedom, 2.457. So 2.46. So that means that this cutoff here is negative 2.46. Now we'll compute our test statistic. Step 4. And so the difference of the two means, that first mean was 6.5 minus the second mean was 7.1. Let me grab that information and bring it down here so we've got it in front of us. And we are dividing by, this is the same pooled estimator times the sum of the reciprocals of sample sizes that we had up above. So this will be our pooled estimator. That was 6.352. We did that right here, so we don't have to redo that. So 6.352. And then the reciprocals were 1/15 plus 1/17. And then if you key this into the calculator, you'll get negative 0.67 to 2 decimal places. So that would be about right here. So that's our t-test, our test statistic. And we can see that that is not in the rejection region. So step 5, our t-test here, which is negative 0.67, is greater than negative 2.46. So we do not reject H0. So our conclusion then is that there is not sufficient evidence to conclude, and it's our alternative hypothesis, So to conclude mean 1 less than mean 2. So in other words, we're going to conclude that the null hypothesis is true, mean 1 equals mean 2. And that's the same thing we were seeing with the confidence interval. 0 was in the middle, so we could not conclude a difference. And then we can perform this hypothesis test on the calculator. Well, let's calculate the p-value here real quick. So our p-value is going to be the area past the test statistic. Our test statistic was negative 0.67. So the probability that t is less than negative 0.67. We're going to use TCDF to compute that probability. So negative infinity, we'll use negative 10,000 as our lower cutoff. Up to our upper cutoff, negative 0.67, and then our degrees of freedom. So let's compute that real quick. So second variables, TCDF number 6. So our lower here, 10,000, upper, negative 0.67, degrees of freedom 30, paste, 0.253992540. And again, notice 2540 greater than 0.01. It's greater than our alpha. Do not reject. So if you're doing a p-value hypothesis test, we would also not reject. So let's carry this out in the calculator using two-sample t-test. So we go to the stat menu, tests, and then we've got two-sample t-test right there, number 4. And it's already carried over our data from the confidence interval. So x1 is okay, s1 is 2, sample size 15, 7.1 second mean, 2.9 standard deviation, and then 17 sample size. This is a less than test, so we want to highlight that less than. We are using the pooled estimator, and we'll calculate. And there is our test statistic, negative 0.67, and then a more accurate p-value, 0.2533. So we were off a little bit because we rounded our test statistic. And if you do the draw instead of the calculate, it'll still give you T and P, but it'll sketch the p-value for you.